Today we're going to explore how to visualize data using a variety of graphs. So previously we looked at a histogram where we put the data in categories and then counted how many data values fell in that category, and that was how we constructed our bars. Each bar represented a category. So now we're going to look at some other kinds of graphs, and each kind of graph we're going to look at has a different purpose to it, or has a different has pros and cons. And each type of graph tells a different story about the data. Some are better for showing comparisons, others are better for showing patterns and trends, others are good for showing how an entire group is divided into categories. And so as we go through each example, I'm going to show you how to create each of these different kinds of graphs. So the first type of graph we're going to look at is called a stem and leaf plot. This type of graph is good for preserving the actual data values while actually showing the patterns. And you could also use the word distribution to see what the shape of the data looks like. Now, what I mean by preserving the actual data is we're going to be able to see each of the individual values in the categories, as opposed to when we look at a histogram, we only see the number of values that are in each category based on the height of the bar, but we can't in that graph see the actual data values themselves. So with the stem and leaf plot, we're breaking it into categories, but we can actually see the values themselves. Now, stem and leaf plot are typically used for smaller data sets. And the way that you want to set it up is we're going to separate each data value into what's called a stem, which is the leading digit or digits, and then the leaf. The leaf is always going to be the last digit in the number, and everything to the left of that last digit is going to be the stem. All right, so when we set up a stem and leaf plot, we have the stem is on the left, and we have the leaves on the right. Now, this data set is already sorted for us. It's already in order. But if you need to, I highly suggest that you put the data in order first before doing this. It's going to make it a lot easier when you create the stem and leaf plot. Now, the last digit in these values, so for the 30 and the 31, our last digit is 0 and 1. And the last digit of this one is 4. So our leaves are going to be the ones place. The stem is going to be the tens place. Since we have values that don't have a tens place, like the 6, 7, 8, and 9, we would just use a 0 for that stem. Now, we go all the way up into the 30s, so our stems are going to be 0, 1, 2, and 3. And then our leaves are going to be the ones place of all the data values. And I would say because it is the last digit in these values. All right, so here's our stems, 0, 1, 2, and 3. You don't have to, but I like to make it in table format so it's easy to line up. But that's not required. All right, now what you want to do when you write your leaves, each leaf is going to represent one of these numbers in this data set. And so because we have 20 values here, because we have 20 values here, we should have 20 leaves when we're done. Now, when you write your leaves down, you're going to come out this way, left to right, like you're reading a book, and you're going to come out and write the leaves in increasing order. So these are already in order for us, so this makes it nice. So we have 6, 7, 8, 9. Now, if I had 2 9s in the data set, I would most definitely put 2 9s in my stem row for 0. I want to make sure that even if I have doubles, they go in here. All right, so 0, 6 represents the number 6. 0, 7 represents the number 7. The stem 0 with the leaf 8 is the number 8, and 0, 9 is the number 9. So now when we go into the next set of numbers, we're looking for any numbers that start with 1. Anything that's between 10 and 19. And again, we need to put them in order. So these, it's nice that these are already in order. So these are what we're doing next. So for the 11, I have the stem 1 and then a leaf. So for the 11, I have the stem 1 and a leaf of 1. For the 12, I have a stem of 1 and a leaf of 2. For the 13, I have a stem of 1 and a leaf of 3, etc. And we're just going to come out. It's also very important that you line up these numbers. The 6 and the 1 are lined up. The 7 and the 2 are lined up. You don't want to make it all squished in on one and then extended on the other. You should be lining up the columns so that we can get a good look at the shape of the distribution. Now, for anything in the 20s, we have a stem of 2. So we have 20. So that means I have 2 and then 0. So that 0 represents the number 20, a stem of 2 and a leaf of 0. Then I have a 22, a 23, a 24, 6, 7, and 8. Now for the 30s, I have a stem of 3, and for 30 I would put a 0. And then for 31 I would put a 1. And that's the last number. So 31 is the biggest number and 6 is the smallest. One thing to mention, if you don't have a value that you need to put in one of those rows, do not put a 0, just leave it blank. Because if you put a 0, the reader might think that there's a value there of 30. So for example, if I had no 30s, no values in the 30s, and I put a 0 there to indicate that there's 0 30s, that means one way to look at this, think of it like a histogram, a small histogram tilted 90 degrees right. So this is a class. Anything in the zeros is a class. So I would have a count of 1, 2, 3, 4 values, the 6, 7, 8, and 9. Think of 1 as the class, and we would have 1, 2, 3, 4, 5, 6, 7 values in class 1 for anything that's between 10 and 19. Okay, so each of these, think of each of these as a class, but this is what I mean by preserving the values. If I can see these values, instead of counting them and making a bar, I can actually see what these values are. I can see by looking at that there's a value of 12 in that data set, right? It has a stem of 1 and a leaf of 2. I know there's a 12 in that data set. Whereas when we're looking at it as a histogram, we don't see these values. We just see the bars that come out like this. So think of this as a histogram turned on its side, but you can actually see the values.